We know that a theme park is usually containing a roller coaster, and it is visited by many people for the simple reason that it has roller coaster. A lot of people like the thrills involved in the ride of the roller coaster. However, when you are riding a roller coaster in the theme park at the speed of 100 kilometers per hour, will you think that why there is no need to use the engine? When the roller coaster is in the reverse direction, why we don't fall over it? In this video, we are going to have a look at the physics of roller coaster.
Why there is no engine requested for the moving of roller coaster? It is related to the conservation of energy. We know that there are different types of energy, such as kinetic energy, potential energy, sound energy, and heat energy. When you are sitting on the roller coaster, because of the left motor, it will be lifted to a very high position. Relative to the ground, the roller coaster has a very large potential energy. The higher position it is, the larger potential energy it has. After passing the highest position, it goes down the hill. Then the speed and the kinetic energy increase. By conservation of energy, the potential energy decreases and transfers into kinetic energy. When the roller coaster passes the first valley, it has a large kinetic energy. Therefore, it can climb up the second hill. By conservation of energy, it climbs up to a height is equal to a height that it went down before. However, due to the friction between the machine parts, the total mechanical energy of roller coaster decreases. As a result, the first value which is passed by the roller coaster is the highest in all values, but the following will have decreased heights.
When the roller coaster is in the reverse direction, why we won't fall off it? It is related to centripetal force, whose principle is more complicated. According to Newton's first law of motion, the roller coaster will continue in its state of uniform motion along a straight line when there is no external force acting on it. That means if the roller coaster is under no external force, it moves along the track of a tangential direction. Nonetheless, there should have a function of the force since the roller coaster goes round. Assuming that the mass of the roller coaster is m, it is moving at a velocity v, and the track is circular with a radius r. The centripetal force required would be mv squared over r. But the problem is, where does this force come from? For simplicity, let's consider the case when the roller coaster is at the highest point. If it has a very high speed v at the highest point, the centripetal force mv squared over r for turning is larger. The weight of coaster mg can supply a partial of centripetal force. But if the required centripetal force is larger than the weight, that means mv squared over r is larger than the mg. Then the rest of the centripetal force will be supplied by the reaction force r.
The larger velocity v, the larger interaction force between the rail and the coaster. Consequently, the coaster will be more tightly attached to the rail and will not fall down. Contrary, if the velocity v is smaller, the rail gives more or even no reaction force, and the roller coaster will falling down riskily. In other words, because of the high speed, the roller coaster won't fall down. Let's try a simple experiment. Prepare a rope and a paper cup. Tie the edge of the cup with the rope, and then half fill the cup with water. when you are swinging the cup, making it to move in a vertical circle. You will discover that no water spilled over. It is because the bottom of the cup supplies a centripetal force to the water.